Hi guys, welcome to 2.1. We are doing just the distance and the midpoint formula, so it's just a bit disconnected from everything else. And we want to get familiar with the coordinate plane. If you are not already familiar with the coordinate plane, it's just important that you understand graphing and the relationship between an equation and a line on the coordinate plane. Okay, so we graph on the Cartesian coordinate system plane. So it's a flat surface and it extends forever, infinitely, in the negative direction on the x-axis, or sorry, the negative direction on the x-axis, the positive direction on the x-axis. I think I was looking at that dash right in front of the axis. The positive on the y and the negative on the y. So it's two-dimensional, okay? We divide the coordinate system into two lines, and what I like to think of them as is number lines, okay? So we have a horizontal number line and we have a vertical number line. The number lines intersect at 0, 0, which we also call the origin of your coordinate plane, okay? When we go left from the origin, we're going negative in a negative direction on the x-axis. When we go right, we're going in a positive direction. Obviously, the y-axis is even more intuitive. When you are going positive, when you're moving positive, you're going up, negative, you're moving down. It also divides the plane into 4 quadrants. Quadrant 1, I'm trying to think if this is counterclockwise. So quadrant 1, and then move counterclockwise, quadrant 2, quadrant 3, quadrant 4, okay? So what we use the x and y axis to find are points, also called ordered pairs, okay? It's just two numbers separated by a comma. Each number represents a distance from the origin. So for example, here's the origin is 0, 0, right? If I'm gonna find the point 3, 2, that means I'm gonna go 3 points on the x-axis, right? 1, 2, 3, that's what that number 3 is, 1, 2, 3. And then I'm gonna go 2 points positive on the y-axis. So this is positive 3 on the x, positive 2 on the y. And so the point is just telling me where I went and how far I went from the origin. I went 3 on the x, 2 on the y. So this is the point 3, 2, the ordered pair x, 3, y, 2, okay? The first number tells us how many units to go left or right. The second number tells us how many units to go up or down. So start at the origin. A positive number is going to move us to the right on the x-axis. The first number is always x. The second number always represents your y, okay? So 3, negative 2, we're gonna go to the right because it's a positive 3 from the origin, but then we're gonna go down because it's a negative 2 from the origin on the x-axis, okay? Or sorry, on the y-axis. The coordinates are the location of the point and the directions to get to that point from the origin, okay? We also have situations like the point 0, 4. All right, remember our first term is always x, our second term is y. So 0, 4 means I don't need to move off of the x-axis. That's my x. X is 0, y is a positive 4. So I'm not going to move anywhere on the x-axis, but I am going to move 4 up on the y-axis. And that's the point 0, 4. Okay? Alternately, you might have something like negative 4, 0. Again, you want to decide which one's x and which one's y. Your first one is always your x. So my x is negative 4, but my y is 0. So I am going to move on the x, negative 4, but I'm not going to move on my y. So this is the point negative 4, 0. Okay? Other things. What quadrant is 3, 2 in? This is in quadrant 1. This one's in quadrant 2, this one's in quadrant 3, and this one's in quadrant 4. These are not on a quadrant, they're on the axis. So that we would say this is on the y-axis, this is on the x-axis. Okay? Another question you will see in my math lab is, if the point -2, -3, so that's this point right here, x is -2, y is -3, if we shift that 1 unit to the left, 1 unit to the left, so x is -2, x would be to the left. So we're going to subtract 1 from x. And 2 units down. So that means we're going to subtract 2 from our y value. So you're welcome to just find it here and say, okay, it's at -2. If I shift it 1 to the left, I'm now at -3, right? -2 becomes -3 because left and right is the x-axis. And then our -3 becomes, -3 is how far I moved it down. 2 units down would become -5. Okay, so you can think about how to do it mathematically. -2, subtract another one becomes -3. -3 subtract 2 becomes a -5, or I'm taking this point, I'm shifting it 1 to the left. So now that's -3, -3, and then 2 units down. So instead of -3, -3, I have -3, -4, -3, -5. So x is -3, y is -5, which is the same point I got by subtracting or adding mathematically. So you can just count, or you can think, well, it's already -2, I'm going to subtract -1. It's already -3, I'm going to subtract -2, whichever you want to do. That is how you would translate a point and find its new coordinates. All right, let's talk about the distance formula. Here's our formula. Our formula is using subscript, so it can be a bit, I'm sorry, I'm very bad at keeping my paper straight while I write on it. The distance formula uses subscripts, numbers that are small and to the right of the variable or even a number. Okay, what the subscript means is, even this guy, it's telling you which point we're talking about. Okay, it's just a way of labeling. It's not necessarily mathematical. Okay, so D just stands for distance. P stands for point. Okay, but P1 stands for point 1, or your first point. P2 stands for point 2. So you'll see x2 and x1, y2 and y1. That just means the x value of point 1, or your first point. Y2 similarly would just be your y value of point 2. Just to make that clear what the subscripts are. Every point has a location with an x and a y, so it's never just going to be, right, we know that. So P1 will have x sub 1 and y sub 1 as its ordered pair. The distance formula is saying that the square root of the second point's x value minus the first point's x value squared plus, so all that plus the second point's y value minus the first point's y value quantity squared is how far away the 2 points are from one another. Okay, for example, here are 2 points. Here's a coordinate plane. Here's the point -3, 1 and 2, 1. It's -3 because from the x-axis, from the origin, I went -3 on the x and I went up 1 on the y. I went +2 on the x, up 1 on the y. These are in a straight line, right? if they're in a straight line, I can kind of just count, right? So the distance between -3 and 2, you could even put it in your calculator, -3 minus 2 is a -5, but as we learned with absolute values, negative distances can't be negative, so that's going to equal 5 as your distance, right? Or you can just count it, 1, 2, 3, 4, 5. The distance between -3, 1 and 2, 1 is 5. You can count up and down, you can count side to side. We can also measure something that is not a straight line, okay? What if I wanted to know the distance between 2, 1 and 1, 0, right? Now that's at an angle, it's not gonna be as easy for me to count. The distance formula, however, will work no matter what 2 points you work with, okay? If you were to put this into the distance formula, it would, your final answer would be 5. Okay. Number 1, find the distance D between the points 0, 2, and 4, 5. So I'm going to say my P1 is 0, 2. Now I'm going to label X1 is 0, Y1 is 2. Does that make sense? Because P1 includes X1 and Y1. So X1 is 0, Y1 is 2. P2 is 4, 5. So I'm going to say my X2 is 4, my Y2 is 5. We good? All right. We now just plug those into the distance formula. The distance between P1, oh no, yes, P1 and P2 is the square root of x squared minus, x minus x squared plus y minus y squared. I'm just going to substitute now. X1 becomes 0. Y1 becomes 2. X2 becomes 4. Y2 becomes 5. Okay, same thing. Distance between P1 and P2 is equal to the square root of 4 minus 0 squared plus 5 minus 2 squared. Keep those minus signs, okay? Even if your numbers are negative, you'll just be minus and -2, for example. So 4 minus 0 is just 4 squared. 5 minus 2 is 3 squared, right? I'm going to do the square root, the squares before and then I'm going to add it, and then I'm going to take the square root. So 4 squared is 16, and 3 squared is 9. 16 and 9 is 25, right? And the square root of 25 we know is 5. So we're going to say the distance between point 1 and point 2 is 5. Next example was -4, 5, and 1, 3. Can't believe I already ran out of space. Same formula, okay? The distance between P1 and P2 is the square root of x minus x squared and y minus y squared. It does not matter if you decide that this is P1 or P2, just as long as it's consistent that you're subtracting 3 minus 5, and then you go back and subtract 1 minus -4. Don't confuse it and say 3 minus 5, -4 minus 1. That's the mistake you could make, but labeling it doesn't really matter. So I'm going to say my P1 is 1, 3. Good. So X1 is 1, Y1 is 3. My P2 is negative 4, 5. X1 is negative 4, Y1 is 5. Now I'm just going to plug those in. So the distance is going to be the square root of, sorry. Not surprised at all that I did that. Negative 4 minus 1 squared plus y2 is 5, y1 is 3, so 5 minus 3 squared. Negative 4 minus 1 is a negative 5 squared. 5 minus 3 is just a 2 squared. Negative 5 squared, because the negative 5 is inside the parentheses, that's still going to be a positive, so that's going to be a 25. And then 2 squared is going to be 4, so that's just going to be the square root of 29, okay? Check it to make sure you cannot simplify it any further. So the perfect squares less than 29 would be 4, 9, 16, 25, right? I can't divide 29 by 16, I can't divide 29 by 9, and I can't divide 29 by 4. So I'm just going to say the distance is that. I'm going to leave it in simplest radical form. But if it's a word problem, you might put it into your calculator. And when you put the square root of 29 into your calculator, oops, you get 5.39, I would call it. Good. Okay. Next, they're asking us to consider 3 points. The point negative 3, 1, negative 3, 4, and 4, 1. Plot each point to form the triangle ABC, find the length of each side of the triangle, and verify that the triangle is a right triangle using the Pythagorean theorem. I'm going to pause the video and draw it because I'm very slow. I don't want to bore you. Be right back. Okay, so I noticed that all of my y values were positive, so I didn't even create any graph below the x-axis. So the point A is negative 3, 1. Put that there. That's A. B is negative 3, 4. That's easy. C is 4, 1. So you can look at the numbers. They are both on the line y equals 1. So that's a straight line. That's a straight horizontal line. If it's a straight line and we're doing the distance formula, you can just count it. So between negative 3 and 4, negative 3 minus 4 is 7, right? Or 4 minus negative 3, also 7, because we're talking about distance, so negative doesn't matter. So that's just going to be a distance of 7. Good. Straight vertical line, you can also count that because it's a negative 3 and a negative 3. So you're just saying between 4 and 1, I think there's a distance of 3, right? The only one that's not perfectly clear to us is going to be what is called the hypotenuse of a triangle, the longest side. Triangle always has 3 sides. The longest side is called the hypotenuse. Good. So this is the only one we don't know. What was this? A, B, C. Okay, find the length of each side of the triangle. So the length of side AB we could say the distance of AB is 3. The distance of AC is 7. Now we just find the distance BC. I guess I made B my point 1. So x1, y1 of B, right? That means B is negative 3, 4. So x1 is negative 3, y1 is 4. C is going to be x2, y2. C is 4, 1. X2 is 4, y2 is 1. The distance, if we remember, is x minus x squared. I'll just write it. Plus y minus y squared. And then you're going to take the square root of it. Now let's substitute them in. We said x2 is 4 minus x1 is a -3 squared. Y2 is a 1 minus y1 is a 4 squared. 4 minus a -3 minus a negative becomes a positive, so that's 7. 1 minus 4 is 3. If you'll notice, that was that, and that was that. That's interesting. The square, or sorry, 7 squared is 49. 3 squared is 9. 49 and 9 is 58. So the distance of the line segment BC is the square root of 58. Good. And you can just leave it as 58. Make sure that you can't simplify it at all. Okay. So this distance, square root of 58. Then they want us to verify the triangle is a right triangle using the Pythagorean theorem. The Pythagorean theorem is that if you take the length of your two shorter legs, square them separately, and add them together, it should equal the square of your hypotenuse squared. So if you take AB, square it, take AC, square it, and add those two together, it should be the square of 58. It doesn't matter which leg is which, right? So we're going to say that this one's the 3, this one's the 7. We're saying 3 squared plus 7 squared should equal the square root of 58 squared. And we already did this, right? We said 7 squared and 3 squared. 9 and 49 is equal to, that cancels that, 58. So yes, we know that that's true because it fits the Pythagorean's theorem, but you can also tell, right? You know that a perfectly horizontal line intersecting with a perfectly vertical line is going to create a 90-degree angle, and that is a right triangle because this is a right angle. Feel free to Google anything like that you don't understand. This isn't a geometry class, so you do not need to know what Pythagorean's theorem does. You just need to use the formula if something like that comes up. All right. We did the distance formula. We know how to replot a point, how to move a point on the coordinate plane, how to label a point, how to decide what quadrant a point is in. Yes, finally, we're gonna do the midpoint formula. If I have 2 points, and we're talking about midpoints, we have two, what we call endpoints, okay? The point in the middle of those 2 endpoints will cut your line segment in half, and your 2 halves will be perfectly equal. That's what a midpoint does, okay? For example, if this was the point -3, 0, and this was the point -3, 0, and 5, 0. I didn't want to make it +3, that'd be too easy, right? If we count between -3 and 5, and we count in 1, 2, 3, right? What is the distance between 5 and -3? It's an 8. Half of that distance is a 4, okay? So at the point 2, 0, I have moved 4 away from this side, and I have moved 4, away from this side. That is my midpoint, okay? We know how to take the distance. Now we're going to find the midpoint. The midpoint formula, it looks like this. I find it easier to separate those two, but that's how a coordinate point looks, so that's how it's written. The midpoint of a line segment from P1 to P2 is, your point is always an x and a y. So your x point is found by adding those two x's, dividing by 2, then add those two y's together, divide them by 2. That will give you your midpoint. For example, if we were going to do this guy, the midpoint from -3, 0 to 5, 0, right? x1 is -3, y1 is 0, x2 is 5, y2 is 0. Good? All right. So that means my midpoint is going to be the point x1 plus x2. -3 plus 5. -3 plus 5. Just put it over 2. Okay, so those were my x's. I put them there. Do a different color for y just for the heck of it. Then I'm going to say y1 plus y2. 0 plus 0. Also over 2. Okay. Now the only math you're doing is you're adding and dividing by 2. You don't need to, we started with 2 points, we're gonna end with 1 point. So we're not doing anything with the commas or the parentheses, okay? You're just looking at this fraction and this fraction. Got it? -3 and 5 is the same as 5 minus 3, so that's just 2. Oh my gosh, guys, my example is wrong. That's why it was so little. This should be a 1. Okay, well, we all make mistakes, right? I'm not gonna. All right, -3 and 5 is 2. But 2 divided by 2 is the 0.1. I'm not color coordinated either. 0 plus 0 is still 0 over 2. So that's still this number. -3 and 5 becomes 2. And then 0, 0. 0 plus 0 remains 0. Just simplify one step further. I'm so embarrassed, I'm flustered. 2 divided by 2 is 1. 0 divided by 2 is 0. So our midpoint is correctly 1, 0, not 2, 0, because there should be 4 between 1 and -3, right? That's 4. And 5 and 1, also 4. Not 2. Find the midpoint between, so that was a straight line. That's why it's easy to find the midpoint. Now, if you don't have a straight line, something like -4, 5, and 3, 2, okay? Add the two x values of the endpoints and divide by 2 to find your x value of your midpoint. Take the two y values of your endpoints, add them together, divide by 2 to find the y value of your midpoint. Good? So I'm going to say this is how I like to do it, the x of my midpoint, okay? And then I do the y of my midpoint so that it looks confusing to me with the parentheses and the commas. The x of my midpoint. Let's talk about we'll just say this one's P1, -4, 5. So that means my x1 is -4, my y1 is 5. we're going to say my P2 is 3, 2. That means my X2 is 3, my Y2 is 2. Good. The X value of my midpoint is the orange one. The Y value of my midpoint is the green one. You're welcome to do it this way. You're welcome to do it this way. Either way, okay? So for my X values, I want X1 plus X sub 2 divided by 2. So I'm going to replace those with my new values. That's a -4 plus a 5 divided by 2. Good. -4 and 5 is 1. 1 divided by 2 is 1/2, or 0.5. Okay, so my X value of my midpoint is 1/2. Now my Y of my midpoint is just Y1 plus Y2 divided by 2. And remember, that's the green one. Okay. Y1 is 5. Oh my gosh. So many mistakes right now. I did Y1 instead of X2. So it's -4 and 3. Luckily, that's just a -1. All right. Y1 is 5. Y2 is 2. Did I do it right? -4 and 3. 5 and 2. See, sometimes when you over annotate, when I over annotate, I get the wrong answer. I've tried to like over show my work and I just mess myself up because there's too many steps. 5 and 2 is 7, right? Divided by 2. I would just leave that as 7/2. You can't simplify it. You could turn it into a mixed number or a decimal, but I like 7/2. So what that needs to become now is a point like this one. So our midpoint is going to be the midpoint of my X, or sorry, the X value of my midpoint, comma, Y value of my midpoint. So that's going to be -1/2 followed by 7/2. I put this into Desmos, so I'm going to show you by sharing my screen. Not. All right, so we have -4, 5 as the red point, 3, 2 as my blue point, and then I typed in what I got for my midpoint, X and Y values, and then I labeled it midpoint, and then I just kind of look at it and think, okay, I'm probably not way off, right? If the midpoint wasn't between the two, I would redo my work, but it's just a way to check your work, to put it into Desmos. All right, next example that I'm gonna get 100% do it right this time was that P1 is -4, 3. So X1 is -4, Y1 is 3. That my P2 is 2, 2. So my X2 is 2, and my Y2 is also 2. So the X value of my midpoint is going to be X plus X, which is, I don't need parentheses, -4 and 2 over 2. -4 plus 2 is a -2. -2 divided by +2. 2 divided by 2 is 1, but negative divided by positive is a negative. So my X value is just a -1. And then for my Y value of that midpoint, I'm just going to say Y1 plus Y2 divided by 2 is 3 plus 2 over 2, which is 5/2. I would just leave it like that. So my whole midpoint is -1 as my X, 5/2 as my Y. And again, I'll show you in Desmos just to make sure that looks okay. Here's -3. Here's 2. Oops. Here's negative 4, 3, here's 2, 2, and then our midpoint was negative 1, 5/2. I would label that. That looks like it's in the middle of those two. All right, last example, we are using the midpoint formula, but they are not giving us P1. They're giving us instead the midpoint and one of the endpoints, okay? So what we're doing is we're using the formula, but we're taking it a step further, we're analyzing it, okay? It's not a new skill, but you're applying the skill in a new way, which is a lot of what my math lab asks you to do, right? So let's talk about what we know. We know our midpoint is 5, negative 4, right? So we know that the x value of the midpoint is 5, and we know that the y value of the midpoint is negative 4. We also know one of the points. Point 2 is 7, negative 2. So my second endpoint, or my first endpoint, I guess it doesn't matter, but it's a 2, so we'll say a second endpoint. Our second endpoint's x value is 7. Our second endpoint's y value is negative 2. And now we need to know P1, right? So we need to find x1 and we need to find y1. We're going to use that same formula. We just don't have the same information. Before we had these 4 points. Now we have these 4 points. Okay? We're still going to set it up the same. So what did it look like over here? I said that the x value of my midpoint is equal to x1 plus x2 over 2. X value of my midpoint is equal to x1 plus x2 divided by 2, right? I'm still going to plug the numbers in that I can, just like we did here, right? I said I know my x1 is negative 4 and my x2 is 3, so I'm going to put them there. And I'm going to solve it for xm. Can't do that this time, but we can give you the xm, right? The midpoint x value is 5. So now we have 5 equals. We don't know what this x is, but we do know that this is a 7 divided by 2, okay? Now that there's only one x, it doesn't need to be x sub 1. It can just be left as x, okay? French people use this way more than I do, and I kind of like it. All right, it was x1, but now there's only one x. I'm just going to call it x, all right, so that there's less information on the page. Now, solve for x. Good. Set up your same equation. Now, I can't just say I can combine these and divide by 2. I need to solve for x. So instead, I say 7's being added to x, and then it's being divided by 2. What is the opposite of that? Right? The opposite of that is multiplying by 2. Or I want to get rid of x being divided by 2, so I'm going to multiply by 2. Okay? These are grouping symbols on top of the fraction. That's why I can't subtract 7 first, because the 7 is still being divided by 2, just like the x is being divided by 2. So I want to take the 2 away before I deal with the 7. Good? All right, so I did that so that those 2 would cancel. On this side now I just have x plus 7, but here I have 2 times 5 is 10. Good. X is being added to 7. Do the opposite of that, get x by itself. 10 minus 7 is 3. Good. Now I can bring back that 1, so x sub 1 is 3. Do the same thing for your y value. The midpoint x value is x1 plus x2 divided by 2. The midpoint's y value is y sub 1 plus y sub 2 divided by 2. substitute in what I know. I know that the midpoint y value is -4. I know that I'm trying to find y1, and then I already know that y2 is a -2. Good. Again, I don't need that sub 1. We've all seen me make a few mistakes today, so less information, lower odds I make a mistake, maybe? All right, same thing. And let me tell you why this is true, right? -4 is equal to y plus -2/2. This is a grouping symbol because if I were to separate it out, what I would have to do is y/2 plus -2/2. The 2 is with both of them. So I don't want to separate this one before I get rid of the bottom one. That being said, we're just going to take the same step we did with the x values because it's a pretty similar equation. I want to get rid of the divided by 2. I'm going to multiply by 2. -4 times 2 is a -8. Y plus -2, I'm just going to call y minus 2. Those cancel. So -8 equals y minus 2. Now I want to isolate y, so I'm going to add 2. Add 2. -8 plus 2 is a -6 because 8 minus 2 is 6. So the y value of my my first endpoint is -6. Now we can go back to Desmos. What is P1? We know that x is 3, y is -6, so it's the point 3, -6 is how we would write it, okay? But then you find out if you're approximately correct by going back to Desmos. Here were our first 2 points. Remove all of these. 7, -2, 5, -4. Are we following a pattern of like adding, subtracting 2 from x, subtracting 2 from y? So we have 3, -6. That looks good, right? Label P2. All right, and that is the end. Thank you so much. I was trying to, yes, back. All right, that's the end of 2.1. So the exam is next, as if this is spring 2013.